Hi everyone, today we'll be solving some problem of the Leetcode. The problem states that we are given with some set of numbers and a target integer, and we has to return the indices of two numbers such that they add up to the target. And another information given in the problem is we'll have exactly one solution to the given input, and we cannot use the same element twice. Let's see some of the examples that we have been provided with. First example, the target is 9 and numbers are 2, 7, 11 and 15. So we see that nums of 0 and nums of 1, which is 2 plus 7, adds up to 9. So we'll return the indices of 2 and 7, which is 0 and 1. So that's the solution for first input. The second input, target is 6 and the numbers are 3, 2 and 4. So from these numbers, we can add up 2 and 4 to get target of 6. So we'll return index 1 and 2 because the index of 2 is 1 and index of 4 is 2. That's why we'll return 1 and 2. Third example is simple and short. Target is 6 and we only have two numbers in the nums array, which is 3 and 3. So 0 and 1 will be our solution. To solve this problem, what we can do is we can take each and every pair from the array and check if it adds up to the target or not. So here I have taken example. So I am looking for target of 16 and the numbers are 2, 7, 11, 12, 5, 4, 3. At top I have mentioned indices also. So what I'll do, I'll pick one number and then take every other number and add both numbers and check if it adds up to 16 or not. So I'll pick 2 and then do 2 plus 7. If it is 16 or not, then 2 plus 11, then 2 plus 12 and so on. Once the array ends, I'll go to the next number, which is 7, then 7 plus 11, 12 and then so on. Then I'll go to 11, 11 plus 12, 11 plus 5. Now we see that 11 plus 5 adds up to 16. That's why my solution for this input will be 2, 4 because 2 and 4 are indices of 11 and 15 respectively. So let's go to the Leetcode back and code here. So I'll be writing the code in Python and in every other language, it can be fairly easily coded. So I in range len nums will take another loop also, j in range I plus 1 then nums, and then if I plus nums of j equal to target, return ij. So here one thing to mention that in the inner loop I have done I plus 1. That's because the problem specifically mentions that we cannot use the same element twice. Otherwise, with this input, if I start from I itself, it will do 3 plus 3 and or in fact take the second example, it will do 3 plus 3 equal to 6. That's why to escape the current element, I have done I plus 1. I'll run this on the given input. Accepted. I'll submit. Yeah, it also got accepted. The solution is only 8-9% faster than the total Python 3 solutions that are submitted. That's because the complexity of this solution is order of n squared. So outer loop takes order n because it runs through all the elements, and the inner loop takes another order of n. So the total time complexity is n squared. That's why this solution is not very fast. And here in the follow-up section, it mentions that if we can solve this problem in less than order n squared time complexity. So what we'll do, we'll take a hash map and keep the indices of all the elements in the hash maps so that lookup can be faster. So in hash map, lookup time is constant. So what we'll do, we'll scan through the array and then check if the remaining part, which is target minus the current element, if it is present in the hash map or not. If it is present, we have both the numbers A and B, which adds up to target. So that's what the idea is. If it is not in the hash map, if differential is not in the hash map, which means that I have to keep the current element and its index in the hash map. So I'll start with 2. So at this time, hash map will be empty, and that's why we don't have 16 minus 2, 14 in the hash map. That's why I'll update the hash map with element 2, and it is present at index 0. Similarly, I'll go to 7. Again, I don't have the differential, which is 16 minus 7, which is 9. It is not in the hash map. That's why I'll update the hash map with 7 and its index 1. And I'll keep on going, and once I reach 5, the contents of the hash map is 2, 7, 11, and 12, which have are the elements that I have seen in the past and its indices. And then at 5, I'll see if my target, which is 16 minus my current element 5, if it is present in hash map. Yeah, it will be present, and 11 is at index 2. That's why my solution will be 4, because my current element that I was processing was at 4, and my remaining part, which is 11, was at index 2. That's why my solution will be 4, 2. So let's try to code this up. First of all, I need a empty hash map. I'll call it scene because it holds the elements that I have already seen in the array. So now I'll do if target minus nums of I in scene. If it is present, we are good. We have found the solution, and the solution is my current elements index and the element which I have found in the hash map, which is target minus nums of I. If I don't find the solution, I just has to update the hash map with the current number, which is nums of I, and its index is at I, and that's it. This will give the indices of 2 elements, which adds up to target. I'll submit this. Yeah, I'll now submit. Yeah, now it is better. It is faster than 61% of the solutions, which is fine. And the time complexity of this solution is order of n, because we are only scanning the array once and there is no nesting of the loops or anything. But the space complexity becomes order of n because we are taking an additional hash map, and its size is proportional to the input array. That's why the space complexity is order of n. So that's it for this problem. Thanks for watching. See you in the next video.